so that TikTok will send the video around to other interested individuals. Thanks for joining. Looks like YouTube is online. Thanks everyone for being here. We'll get started in about 10 seconds or so. Feel free to drop a comment and let me know where you're coming in from. Thanks again for being here. Okay, great. John here, software engineer with about 10 years of experience, and we are working on Leetcode for interview prep to get an awesome FANG job. Hopefully it's remote, $1 million a year, and free lunch. That's what we're going for. That's not too much to ask, right? Okay. In front of us, you can see the events calendar. So currently this is a lunch coding stream, 3 p.m. Eastern, noon Pacific. And then there are these 9 p.m. streams as well, Tuesday, Thursday, Saturday. And small groups, which are not open to the public. I'm going to quickly show you how you can register your interest and join the waitlist for a new set of small groups that'll be starting up in the next 1 to 3 months. Isaiah on YouTube, welcome, welcome. By the way, if you're on TikTok, you can check the link in my bio. You'll have a link to YouTube or Twitch where you can see the full screen. Okay, quickly, let me show you how to do this calendar thing, and then we'll get into some code. So here I'm going to sign in. Go over to my account settings, scroll down to the bottom, and you can see the flag or checkbox to indicate that you are or are not interested in an expert-led small group. You can also mention if you want to join a hackathon, and if a bunch of people say yes, we'll have a hackathon. You see how this works? You can also mention if you are open to work. I guess that checkbox is further up. But if you're open to work, you can list your profile here, check open to work, and you will be mentioned in the browse all profiles with the open to work tag there. Okay, now on to the Leetcode stuff. So tap the blog, go to article 3, and this is the latterly Leetcode kata. These are the core data structures and algorithm problems that I suggest that you should learn to prepare for big tech interviews. You can read through the reasons for that suggestion here. It's evidence-based and results in a high percentage coverage of the normative questions asked in big tech. There are 2 forms. There's the standard kata and the extended kata. The standard kata is a dozen long. Once you have mastered the kata, you can complete all 12 problems in under 2 hours. Isn't that wild? Think about that. And what does the word kata mean? If you're not familiar, this has to do with martial arts. So you're repeating the same exercises over and over. So you could basically consider yourself a code ninja. You're becoming a code ninja. And you can get through all of these problems within 2 hours. And then there is a 20 long problem set for the expanded kata. And I haven't timed it, but maybe you could do that one in 2 hours too if you're really awesome. I'm sure someone out there could. For solutions, you can tap on blog article 7. Here are some of my preferred solutions. You're welcome to submit your own here. And then there is a YouTube video playlist, which goes well beyond the code. And so here is the latterly Leetcode kata Python playlist that covers the full standard kata. Some of the problems will have multiple solutions. I found hearing the solution from multiple creators was helpful for me to clarify my understanding of the problem and the solution. So course report, for example, has 3 solutions, all in Python. And there is a Java and JavaScript playlist available as well. So to check this out, you go to the Latterly YouTube channel, tap the playlist button, and look for Latterly Leetcode kata and the suffix based on the language of your choice. They're not always going to be adjacent. So you can see that you have to sort of skip one to get over to Python, and that's very common. All right, so the focus of today's stream is that when I was building this playlist, I noticed something counterintuitive compared to my Leetcode practice yesterday. So yesterday I was working on longest substring, so we'll open that up. Let's see, where's longest substring? I'm going back to Article 3. And so here's longest substring, and I didn't get this one right. So I'm still working on sort of mastering this problem. One of the things that I thought that I got wrong was that I used a set instead of a hash map. By the way, there's a playlist also of my Leetcode practice. So you can go see me mess up yesterday. I got a couple questions right, and then this one I got stuck on. So we're jumping right back onto this problem. And I thought that it was the right thing to do to add a set at first. And then when I submitted the problem and it failed, I thought maybe that's the root cause of why I'm wrong. I had left myself this good explanation from, I don't know, months or maybe years ago, whenever the last time I was working on this problem was. And this explanation uses a scene map, a hash map. I thought that's a pretty key difference from what I did. I'm using a set, they're using a hash map. Why are they using a hash map? You can store the index literal of the location where a character was seen, where a char was seen. And that seems to be extremely performant, right? Why would I slide up and down the string if I could just jump, if I could skip in wise compute, in time complexity? And so I thought, well, that's probably what I did wrong, and I'll get it tomorrow. And I was planning to basically implement this. Then I saw the Neetcode video, and I hold Neetcode in very high regard. You might catch me making jokes about Neetcode, and the reason is because I hold it in high regard. I wouldn't even be talking about Neetcode if I didn't hold him in high regard. The laterally Leetcode kata I view as building on a bunch of things, but Neetcode and Sean Prashad's patterns are two of the biggest building blocks under the laterally Leetcode kata. So big fan of Neetcode. And when I look at their longest substring explanation, if I recall correctly, he's using a set. So he's using a set, which was the intuitive thing to me to do. But then now I'm back to square one because, well, this link that I had uses a set. Neetcode, or it uses a hash map. Neetcode is using a set. And thus the title of today's stream, is Neetcode wrong? Is Neetcode wrong? To set a bit of precedent for this, it wouldn't be the first time that Neetcode had a suboptimal solution. What do we mean by wrong, by the way? I don't mean that it produces an incorrect result. I'm very confident the Neetcode solution will produce a correct result, but it might not be optimal in performance. You can imagine with a set, a Boolean indicator about whether I've seen a character, and then I say, oh, I've already seen it, so I have my longest substring. Now I need to reset my left. How we reset the left will influence performance. So the implementation that I did was a backtrack and rewind. And you can see that this would be slower than an ahead of time cache. If I just knew the index to jump to, that would be faster. So that's why I like the scene map, okay? So when I say is Neetcode wrong, I'm kind of asking the question, is Neetcode doing something similar to what I was intuitively doing? So I would be wrong too. And basically what we're going to do is we're going to test both solutions and look at the performance, and whichever wins will be the preferred approach. That's what we'll do in this video. But before we get to that, let me show you a case with some precedent that shows you that the Neetcode solutions are not just trivially wrong in some cases, not just a few milliseconds slower, but sometimes slow enough that they no longer pass the Leetcode submission. They will time out in some cases. Word search is a key one. So he gives a correct solution, correct in the sense that it provides the right output, but it times out. His solution is 3 years old. At that point in time, it was acceptable, and now it times out. So Leetcode itself changes the performance standards over time. This is something interesting to note. Okay, and so if you watch the video, he'll give you a solution. Very intuitive, great explanation, lots of graphics. But if you go apply that solution, it won't pass. It won't pass. And you'll be like, well, why doesn't this pass? Neetcode says so. And that's where the idea of Neetcode wrong comes from. And you can see the answer in the comments. Let's see if I can find the comment that has it. There's a block of code that allows some short circuiting, basically. TLE error, which I think is the timeout error. Yeah, time limit exceeded. So getting TLE error, I found the answer when I scrolled before. Okay, so I think that might be a solution. That's not the one I had in mind, but that might do it. Minor optimization, that's not what I had in mind either. We'll time box this. I won't drag you around for this. Oh, to prevent TLE. Yeah, okay, so this is the comment that I ran into. Apparently there's a few comments where people have different solutions to overcome the TLE. I don't know if this is like the world's best one, but the point is that if you take the solution literal, in this case, you'll get a time limit exceeded. So is that also true in the case of longest substring? A lot of these videos are 3 years old. So is this also out of date? Okay, enough with the setup. Let's get to the test now. So where's the full Neetcode solution? I'm scrolling all the way to the right, and I'm just going to reproduce the solution and submit it, and we'll time it. In fact, let me grab the URL here. And what I'll often do with these kata is I'll wipe out my solution to the problem, but I will retain my favorite explanations up top so that if I get stuck, if I can't remember, I can refer to them. You can always click the solutions button, but sometimes the solutions are not particularly good. They're not really intuitive. They might be for a different language. They might be suboptimal. So it's worth curating the best solutions. And I just hold them in a comment up here, which I don't really feel is cheating because reading the URL doesn't like give me content of the solution, right? So I just sort of leave them there. Okay, so let's just reproduce this. We're going to have a char set is a set. He'll set L in res. So char set is a set. L is 0 and res is, what is res? Is it also a set? Res is 0. Oh, right, we're serving an integer. Okay, so I think it's a while loop and then eventually return res. He's going to do a for in range. Okay, for in range len s. For in range len s. And there's a while inside the for. That's okay. That doesn't automatically multiply the complexity. While SR in char set. While SR in char set. You might also say R of S, but then it reads right to left, which is kind of weird. While SR in char set, you might be thinking, oh, look at this camel case. Isn't that non-idiomatic for Python? This is Leetcode. Don't worry about it. No one cares. If you want to do underscore, that's great. Go for it. And I probably would too, but that's not, you don't get to throw heat at Neetcode for that. And in your interviewer will almost certainly not care. You might, okay, the truth is you might have 1 or 2% of your interviewers who may go on to ask you about variable naming convention, like idioms and things like that. If you have a good answer, go for it. It's your time to shine. If you don't have an answer, that shouldn't penalize you much as long as you can solve the problem. Now, if you cannot solve the problem and you cannot give details about good practices like variable naming and so on, if you have 2 red flags, that's a red flag for you, right? What I'm trying to say is that your interviewer may ask about variable naming out of trying to help you and salvage your interview, as opposed to trying to nitpick on you. Although you do get the nitpickers too, frankly, in my book, that's their red flag. Like I wouldn't want to work with a person who is, oh, they got the optimal solution, but they used a camel case in Python, so I flunked them. That's absurd. And yeah, that's really bad. Okay, I think I copied this properly. Let's look one more time. Char set lres, I'm just scanning the left. Char set lres. We have a for while, char set l, char set l, char set. We're adding s of r, sorry, we're adding r of s. Define res, return res, define res, return res, or assign res would be better to say. Okay, so it looks like transcribed. What did I do? Invalid syntax. My for in range. Oh, I didn't give a name to the for in. What is the name? For r in. Why did we pick r, by the way? What does r mean? That is a case where it's like, I would not be writing this the same way that Neetcode wrote it. But that's not to pick on Neetcode. I would just write it differently. Okay, so this was accepted. So all the worries about timing out, notwithstanding, here we beat 68.5%. I'll run it 3 times and we'll take the max. Okay, it looks like the same and the same. So we're reliably at 53 milliseconds, beat 68.5. Now let's do the alternative implementation and see if it's faster. So apparently they're both fast enough. Whether you go for the scene map or you go for the set, they're both fast enough. But which is better? Just because it's fast enough today doesn't mean it'll be fast enough tomorrow. We already saw that precedent, right? So better to go ahead and study the better practice. Unless it's like wildly unintuitive, then fine. Go with what is intuitive to you, because if you can't remember it at interview time, what's the point in studying it? But if you find that you can remember it either way, go for the better one, right? Even if it's linearly better, go for the better one. And I'll tell you that both of them are intuitive to me. Arguably, Neetcode's set-based solution is more intuitive to me, because that's actually what I naively implemented. But once I made the adjustment of storing ahead of time the fixed location, that's like a really intuitive and, like, frankly, a good reason for a speed up, even if it's a linear speed up in my book. But it could all be a lie. Maybe it's not a speed up at all. Maybe it's like a 1 millisecond difference. And that is what we're curious to learn. That's what I'm curious to learn right now. Okay, so did I copy this over literally correctly? And I can pick on this implementation too, right? Maybe that's being fair to Neetcode, is not just picking on them. Like this, like R of S of scene, these nested lookups to me are hard to read. I would almost always extract them. I would call this like priv index. And then I would say something like that. Okay, so I would just extract it and name it, literally, because, so this is a medium. It's less important in a medium, frankly. And this is what, 20 lines? Okay, if you knock out the comments, it's less than 20 lines. But if you get into a hard problem that's going to have like 3 helper methods and you're at 50 lines, I need it to be readable for my own reference, or I will get lost in the sauce. So that's a pro tip for me, is use best practice variable naming. It's going to make you look good even if you don't get the optimal solution to the problem. Your interviewer can still get positive signal on you, and it's just going to help you solve the problem, dude. You know what I mean? Like, anyway, that's the case for me. Isaiah asks, is this a problem that only mostly seniors would see, or is this something a junior would face as well? It depends on the company. So this is a Leetcode medium, And this is a very commonly asked question. It is even asked at the junior level in FANG, in big tech. But it would be probably one of the harder ones that a junior would see. And it would be definitely one of the easier ones that a senior would see at a Facebook, for example. Noting that Facebook has a notoriously hard coding round, okay? Even within FANG, the severity of the coding round varies because FANG has its own styles. We talk about FANG as if it's a monolith. There's a lot of overlap on the skill matrices and the rating and performance reviews, but there are unique pieces to each company. Think about the Amazon leadership principles, okay? And one of the things that's kind of unique, and this varies over time, so making timeless advice here is hard to do. But in general, Facebook's coding round is considered to be harder than Amazon's coding round. So I would be surprised, I would be very surprised to see this at an Amazon junior coding round. I would only be slightly surprised to see it at a Facebook junior coding round. Did that help? Hopefully that answered the question. One last asterisk I'll put on that commentary is, I said it varies over time. As an interviewer on the job market, how do I know ahead of time the style of variation? So John said it varies over time. That's not very helpful. I want to know right now, am I likely to see this problem or not? There's two answers. One answer is you can go to Leetcode Premium and you can see the companies, like the questions that they're asking. So go over to the problems. I forget where exactly the link is. This UI gets kind of busy for my taste. Yeah, so here you go. Amazon Spring 23 high frequency. So just look at the list of high volume asks on Leetcode. And you can use an interviewing.io that is arguably an even better solution. I will be using interviewing.io for my preparation in a few days. I'm not using it today. They have company targeted coaching plans where you will work with an IC at that company. There's a delimited set of companies they support, but it includes FANG. It includes Meta, Instagram, LinkedIn, some others, Google. Okay. And they will give you like the tea. Like they will tell you what's being asked today. I remember last time when I did the Meta loop and I got to the final round, unfortunately, I didn't get the offer at senior level. They wanted to like down level me too, which didn't feel great. So I passed. But one of the tips that I got is like, hey, Meta is not asking DP right now. Like you just don't even need to study DP right now. And that saved me a bunch of time. You see how that could save you a bunch of time? So that's one way that you can know is you can directly interrogate the recently asked questions through a tool like interviewing.io or Leetcode. The second way that you can know is whether the company is generally hiring at a large velocity. And if they are, they will often lower the coding round bar. They will often lower the coding round bar to get more ICs through. Does that make sense? If a company is hiring with less velocity, you can expect to be asked harder questions, basically. So that's just a rule of thumb. You good? Welcome in. Should I start a company and become a billionaire? Maybe. If you're capable, I would say why not? But the if you're capable is like a big question. Isn't that bad thinking? Why shouldn't you know all elementary algorithms and be competent? Yeah, that would be nice. Yeah, I'll work on that. Thanks. I'll work on knowing all elementary algorithms and being competent. That's what we're working on, right? Aren't we working on learning the algorithms and being competent? Okay. So I copied it over. We were verifying whether my transcription was proper. So, okay, let's look one more time. Scene L output, 4 in range. Scene L output, 4 in range. It looks good. Did I clip the return? Return is here. Everyone's happy. We're looking gorgeous. And the question is, can we beat 53? So we have the current runtime on the left. Let's send it. Oop, the syntax is invalid. Did I copy something wrong? Line 19 has an else. What's wrong with the else? I'm not seeing it. Let me get rid of these comments. Maybe it's making it harder for me to see somehow. Okay, that worked fine. There's something in the comments that threw off the, I don't know, maybe like the compiler was getting tripped up on the comment somehow. I'm not sure. 55. Oh, Neetcode wins again. It is slower. I'm a little bit mind blown. I think this is going to depend on the empirics of the test cases. So you can see that using a hash map and jumping to the index has some overhead. And I guess depending on the particular test cases, that overhead may or may not be worth it, which means they're roughly equivalent, which means as an interviewer, I'd be fine with either approach. Still, I'm surprised. I thought those Leetcode stats were based on server usage. I've submitted same code and got different results. Good call. Yeah, let's submit it a few more times. So I did 3 trials with the other solution, but I only did 1 here. Let's do 2 more. 53, 55, 48. We beat Neetcode. Did we beat it on average? 53. Guys, I'm a programmer. I don't know math. 53, 48. What was the other one? I don't know. 53, 48. I think it was about the same on average. But it was 55, wasn't it? It was 55, 53, 48. Doesn't that still beat it on average? Bro. There's something called streaming brain. Like if you're trying to stream and like think at the same time, it's legitimately harder in my opinion. But I think we beat Neetcode on average over here. So it's 52 instead of 53. We literally beat it by 1 millisecond. Okay. So remember that part where I said, hey, it doesn't TLE right now, but it could in the future. I suspect that if Leetcode itself was going to raise the TLE bar, it wouldn't raise it by 1 millisecond. Like, I think it's going to have to meet some like threshold of significance, like 10% or 5% or something. So I think they're going to be like basically equivalent. Meaning I am content to go with the Neetcode route, which does appear more terse, doesn't it? So here we have, let's go for the one that's easier to implement as a developer at interview time. So the Neetcode solution, although it's a whopping 1 millisecond slower, take the L Neetcode. It's implementable in 13 lines versus 17 lines. No, that's not quite fair. 2 of these are mine, so 15 lines. So what, you're getting an extra 2 lines? You have the same 3, so scene, like, it's a map instead of a set, but it's basically 3. So what's the difference? The difference is going to be within this range block. Let's read that. You see how this is helping us study, by the way? You might say, oh man, he's just looking at solutions. Is he even like learning the answer to the problem? The answer is like, yeah, we're actually comparing and contrasting solutions at a pretty low level of detail, which is going to be really good to burn this into my brain. Hopefully, we'll be able to tell tomorrow. Subscribe to the channel, like the video. Monday through Friday streams, Leetcode for lunch. And yeah, when you drop in tomorrow, we'll be able to see whether or not it was burned into my brain today. But I'm going to hypothesize that it will. And even if you take me out of the equation, just look at the external literature on recall. Yeah, compare and contrast is good for recall. I mean, there's other better strategies, but it's definitely an effective strategy. So while while the character is in the character set, I would call this cur. I would call this cur or cur char or something like that. So while the current character is in the character set, in other words, while we have already seen it, is already seen, was already seen, I'm going to go ahead and write my form of this. I'm going to write my form of this, which would be even better for recall. So let me read it in English. As we step through a string called S, while we are looking at a particular character, if we have already seen that particular character, move my left pointer to the right. So it's a sliding window, right, is the overall approach here, if that wasn't clear. Why is this problem in the laterally kata at all? The answer is because the sliding window algorithm is an incredibly powerful pattern. It's not just the concreta, it's the abstracta that is of relevance to us as we prepare for big tech interviews. So the general pattern that we're going for is the sliding window algorithm. And notice that in either case, whether we use the hash map or the set, and by the way, I'm going to now delete good explanation because the Neetcode explanation was better. But regardless of the structure that we use, the pattern would be the same. Isn't that interesting? So sometimes when people speak at a high level about whiteboarding interviews in Leetcode, they might talk about data structures and algorithms. And it's sometimes heard as redundant that by declaring the algorithm, haven't I implicitly defined the data structures? Like a queue is a queue, right? If you're going to do a BFS or DFS, you need a stack or a queue, right? That's only sometimes true. That's only sometimes true. It's more precise to specify them both. Because in cases like the sliding window, there are multiple structures that can implement the pattern. And sometimes it does impact the results literal, the runtime, or the memory complexity. So in the case where we need to deduplicate tuples, a set gives you that basically for free. You add, it's going to replace instead of append or something like that if the tuple prior existed in the set, which is not the case for a hash map, right? It kind of is if you set it to the same key literal. All right, anyway. I feel like you can make a lot of solutions equivalent if you add enough caveats. Yeah, the set doesn't need a key. They're different structures. So ignoring the caveat, like the fact that you need the caveat shows that they are importantly different. Okay, so yeah, while we've already seen this character, let's move our left pointer. So we're like kind of like a caterpillar, like growing and shrinking. And then it turns into a butterfly, and that's how you get the $1 million remote job with free lunches. My sliding window caterpillar turned into a billionaire butterfly. Okay. And then, yeah, we just say that the result, I don't like this name RES. Popular in like competitive programming to just do these truncated names. I would say longest substring. Call it like longest substring. So like while we've already seen the character, we're going to move our left pointer to the right. Then we're going to re-add it, right? So we drop it and then we re-add it. And then we're going to say, hey, whatever the length of the string is now, the new substring that we've reestablished after we move right one and then we move left however many times needed. So this new substring, the largest overall substring is just the max between that and whatever the solution was previously. Cool, let's see if I can implement it without looking at the solution now. This is going to be embarrassing when I fail on this. All right, so now we'll go for the solution and then we'll wrap up, like we'll actually implement a solution and we'll wrap up the stream. So let's start as if I had gotten this problem for fresh, as if I hadn't been looking at this for 30 minutes. You good says solve it in assembly. No thanks. No thank you. So if I had just gotten this question now, I would start by reading the prompt. Longest substring without repeating characters. Given a string S, let's find the length of the longest substring without repeating characters. Example 1, ABC, whatever, whatever. The answer is ABC with a length of 3. And so the result is an integer literal 3. And we know that whenever I hit that second A, I'm having to reset left. And then I'll look for ABC again. I'll find it. So there's 2 equally lengthed substrings. And then I'll go from the second ABC and I'll hit a B. Then I'll have to move left because I'll be duplicate on the B. So I'll have to move left twice. And then it'll be CB, which is length 2. So it doesn't raise the max. From CB, I'll move once more and I'll hit another B, which is another duplicate. So I'll have to reset and get only the substring B, which is of length 1. So 3 wins overall. Make sense? Now we can just imagine in the limiting case, there are no repeated strings, which would mean that we need to search O of n. All right, so here's my target time complexity is ON for worst case, because in the limiting case, there are no repeated chars. So I must inspect all chars. Okay, so we did the time complexity. What about memory? For memory, I need a cache of seen chars. So the memory complexity is O of n in the worst case. Because in the worst case, when I don't have any repeated characters, it really be like O(n minus 1). I would be storing every character. And then I would get to the end and go, oh, they're all unique. O(n minus 1) is asymptotically equal to O of n, right? So we just call it O of n. Okay, so now I'll make scene. And a scene map and a scene set are both like really intuitive to me. It's like once you've seen it, you can't unsee it, right? Now it's almost more intuitive to think about storing the position instead of storing the Boolean indication of whether a char literal has been seen. And it doesn't matter. Like, why are we spending time on this? Because we saw the runtime data. Oh, it's really difficult. It's really difficult to like get away from your intuition once you have it. Now that I have the intuition that I can store the index literal and jump to it instead of 1, 1, 1 and like finding it. Now I like want to do it. So I'm going to go for the scene set. Okay, and then the longest substring will be 0. And I could even prefix this I if I want to make it clear that it's an integer. What else do we have? There was a third element here, but I can't recall it. So for cur char in range S, to do, and then I'll return I longest substring. Let's go ahead and spell it out all the way. Left, I need my left and right to compute distance. Left is going to start at 0, right is going to start at 0. Okay. So for the current character in range S, if current character is in we just say in, seen, then last seen IDX is seen cur char. And left is going to be last seen IDX plus 1. Would it be the index or the index plus 1? Let's say in the case of a string BB. In the case of a string BB, I at first haven't seen B, so I store it, and then I have seen B, so I want to jump my left pointer to index 1, not index 0, because index 0 to 1 will contain the duplicate. I'm trying to avoid the duplicate, so I want the plus 1. Make sense? Okay. So if it's seen, and really we're going to be incrementing this thing like every time, which is probably why the other solutions didn't use it at all. They just put it right here. This would be for Kirchar and S. Okay, so if I've already seen it, then I need to move my left pointer. Great, and that's pretty much it, I think. So here we will say that the cur distance equals foo, and then this is max of cur distance and whatever it was previously. So what's the current distance? The current distance is right minus left plus 1. Again, consider the string BB. I move my right hand to the second B. Now I have a duplicate. My left hand needs to jump to the second. So they're on the same position. If I take the difference of their position, it would be 0. But the length of that substring is not 0, it's 1. So you need to add 1, because when you difference the current position, you still have a substring length 1. So you have to add that 1 offset. Boo, failed. Okay, let's see what's wrong with this. My output was 9, but we expected 3. The whole thing is going to be 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Oh, the whole thing is 8. Wow. Well, that's very wrong. So I've gotten the entire length of the string plus 1. It's as if left was always 0. It's as if left was always 0. I'm not storing that I've seen a character. That's the problem. So left is always 0. So now let's declare that I've seen it. Seen of this current character is this current index. I don't know if I like calling it right. I guess that will be the index. That's fine. I think we can call it right. So the output that I got is 4 when we expected 3. All right, this seems a little better. So now I've got the 3, which is the correct thing, 1, 2, 3, and then I've added 1. So what has happened here? I think right might be off by 1. Let's print that. So the first value of right, is it 0 or is it 1? Yeah, so right is off by 1. That's the issue. I think we can just do this. Is that super illegal? I guess not. Here it was illegal. Okay, something feels illegal about that way I just slapped the right +1 at the end. ABBA. So my output was 3 when we expected 2. Yeah, so something about the way that I'm writing the index is wrong. EDI, hello. Is it Eddie? Is it Edi? Thanks for being here. By the way, if you're on TikTok, tap the screen to give it likes. You can give it more than 1 like on TikTok. That'll tell the algorithm to send it around. If you're on another platform like LinkedIn or YouTube, thank you so much for being here. Please subscribe to the page and like the video so that the algorithm will send it to other people as well. Goal here is to spread education, spread awareness. Also check out latterly.io where you can join the Discord. If you have a question, if I don't get to it during the stream, you can come ask questions on the Discord 24/7. At latterly.io, there's also a chat bot for 24/7 support. Okay, so let's not be so creative. Neetcode did it for us. Range len s. Let's go ahead and do that. And cur char will be right idx of s. So we'll get rid of this extra exterior pointer and we'll just use the interior. So here's the right IDX, here's the right IDX. I don't need this any longer. It makes the thing actually a little more terse, which is nice. And left, I'll specify as left IDX. So I know it's the index and it's not just a value. I'm double checking left to make sure that I've updated all the variable names properly. Now I'm double checking right. Right. How about now? Now we're accepted. What about over here? And we're still wrong. Bummer. So close. Okay. So what am I doing wrong that Neetcode did right? By the way, if you get a problem wrong, like I did, don't feel bad. Don't feel bad. You have more time to practice, and getting it wrong and feeling the pain of getting it wrong and drilling into where's the difference between what they did and I did is extremely reinforcing on your memory. So in some ways, getting it wrong is a good thing. I mean, I know it doesn't feel that way, but getting it wrong is a good thing for your longer term recall. You don't want to get it wrong in an interview. But getting it wrong at practice time, we learn by making mistakes, growth mindset, yo. We don't want to get it wrong in an interview, but getting it wrong at practice time is actually an opportunity for reinforcement. Because now that I got it wrong, I'm going to drill down into what was the specific line, So let's do that. So I've initialized properly. I'm very confident about that. We'll go check, but I'm very confident the initialization is proper. We eventually return properly. 4 in range len s. I think that's right. So something here is going to be wrong. Maybe it's my jumping. Oh, okay. So here, I think I need to validate that this is not out of bounds. I think that's my issue. Let me try that and let's see if it works. So this is going to be the max of this thing, or length s -1. No. Sorry, that should say min. Okay. Still wrong. Okay. Well, this protected us from going out of bounds, but apparently that wasn't helpful. So we've seen the current character at the right index. Yes, that seems proper. That seems proper. Boo, I'm not sure. Okay, let's go take a look. It's the remove and add, which is different. And then max r minus l plus 1. While seen. Ah, no, that's the difference. He's saying while seen. I'm saying if seen. Okay, so if we need to drop multiple letters, I'm not dropping enough is my problem. That's why my number is too big. Perfect. This is the critical problem. He's saying while seen, I'm saying if seen. Okay, let's do this. While current character in scene. Move left pointer on sliding window to avoid containing a duplicate. Okay. My left index is adjusted. Good. So the while is non-terminating. We can break. That guarantees we eventually break. No, it doesn't. I need to actually increment it. Oh, great. Last seen IDX. Yeah, why does the jumping approach not work? So basically what we're seeing here is the jumping approach is not working. Seen current character, that should store the index. Okay, I'm not updating current character. That's my problem. So I'm not updating my current character because current character is calculated from the right hand. And I'm not moving the right hand, so I wouldn't want to recalculate the current character. But I need to remove it from scene is what needs to happen. So I could use del, del. I could also set it to none. Let's see what happens here. Last seen current character. So we'll use it and then delete it. So we'll use it and then delete it. After moving left, indicate that it isn't seen. So after moving left, so let's move left. So after moving left, let's indicate that char isn't seen anymore. I don't really know that I need this expression. Let's leave it there just to minimize our changes. Okay. And I'll submit it, but I'm probably going to get rid of that expression. So we still have this edge case that's biting us. Okay, that didn't help. So while the current character in scene All right, let's step through this test case, ABBA. So it's going to have a length of 4, 1, 2, 3, 4. Okay, so I'm expecting 0, 1, 2, 3. We can go ahead and print right IDX to confirm that. Yeah, print starts with 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7. So an 8 length character goes up to 7. That makes sense. So this will first be 0. So right index is 0. Current character is S of 0. So it's A. Current character is A. While A is in scene, it's not in scene. So we move on, and then we say, current character. Yeah. We now store the key A with the value of the index 0. We now store the key A with the value of the index 0. Then I calculate the distance is 0 minus 0 plus 1, which is correct. We have the substring A. And now this becomes the max of 1 and 0. It becomes 1. Great. Now we're on to the letter B. Kerchar is B. B in scene is false, so we come down here. Now I have B1. The distance will be 2 because it will be 1 minus 0 plus 1, which is 2. The max of 2 and 1 is 2. Now we come up and we get another B. B is in scene, so we enter this loop. The last scene index is 1. So the left index becomes the minimum of 2 or 3. So it becomes 2. In other words, right and left are now both pointing at 2, which seems proper. After moving left, indicate that the current char isn't seen anymore. We delete it. Okay. Now this B is going to become the right index. So this will become A0B2. A0B2. Yeah, there's something about this stale A that's bad. Something about the stale A that's bad. Anyway, let's keep going. So now the current distance is right minus left plus 1, which is going to be 2 minus 2 plus 1, which is 1, which is expected. It loses the substring battle. 1 to 2, 2 wins. And now we go through another loop, and now we are on the final A. So this is a value of 3. The third index of ABBA is A. A is in scene. Yes, it is. Last scene will be 0. And now the left index moves to the left, which it shouldn't do. That's the illegal move. So my left should never move left. My left should only move right. So So one thing that I can do is say that you are the max of left IDX and this thing over here. So you actually never move to the left. And that solved it. That solved it. Cool. Okay, so the problem is that we had stales outside the window. That was the problem edge case. This is a pretty intuitive solution to me. However, it's slower, isn't it? Let's run it a few more. Let's solve it a few more times. Oh, sorry. Submit it again. Yeah, so this is on the slow side. And the reason it's slow is pretty clear. The reason it's slow is pretty clear is that I have a nested max and min here. So how can I do this in a more intuitive way? How does Neetcode handle stales? It doesn't. It just doesn't handle them at all. Yeah. Yeah, so the there and back again. The set is better. The set is better. So we started with the set because it was intuitive, because we want to know if we've seen something. So we reached for the set because it gives a Boolean indication. It's the simplest representation. Then I said, well, what about a hash map? A hash map could be better because it gives us a cardinal indication. It doesn't just give you the Boolean indication of seen or not seen. It gives you the location of where it was seen, the index literal. And then we ran into the complication where that index literal could be stale. So one solution is to min-max on the index literal. So you bind it into the window. That's what I did, which is a little bit slower, although it works. The other solution is to realize that you don't need to deal with stales at all and go back to the set because it's irrelevant. Why is it irrelevant? Seems like empirical coincidence. It does to me. I mean, maybe someone can school me. Let me know in the chat. But it seems to me that the min-max approach, as slow as it looks, and we've just submitted it, as slow as it looks, it could be more efficient if the test cases were of a particular sort, basically. Yeah, I'm happy to be wrong about that. Cool. I'm going to retain both of these solutions, and I'm going to prefer Neetcode. And I'm going to try to think about, if I'm an interviewer, what's the twist on the problem that I can give you such that the min-max is worth it? Is there any such twist possible? The answer would be the while. You would need to have a long stretch on that while. Let's try to construct a test case. We basically want to make the jumping more performant than the while loop. Let me make this an if again. Does it still work? Yeah, it's still going to work. Oh, wow, that sped it up a lot. So this is a jumping pattern. And the runtime is ranging. Yeah, I saw it go into the 50s, but it's typically somewhere in the 60s. Now it's hung on something. Okay, so let's try to make a test case. Can we do a custom test case? Contribute a test case. Okay, so here's PWWKEW. What I want to do is have like a load of W's. Okay, let's see. I'm going to refresh the page. So here's my test case 1 with a load of W's. And the output is 3. Runtime 41 milliseconds across all 3. I'm not actually sure what that means. Is that the runtime across all 3? Oh, that's crazy. I didn't know you could make your own. Yep. This is on the premium. I don't know if you can do it on the on the regular. Here it's not letting me edit the string anymore. Do I need to refresh the page again? Test case. Oh, it's because I need to click the word test case. Let's do a, so I want to do the jumping instead of the while. Let's try it like this. So I'm going to do a B and then a bunch of letters, and then a B, and then a bunch of letters, and then a B, and then a bunch of letters, and then a B, and a bunch of letters, and then a B. Okay, so 33 milliseconds. It looks like that's across all 3. So this is 33 milliseconds with the jumping approach. I kind of want to make this even longer. Now we're at 44. You attempted too soon. Okay, sorry. 38. We're getting the range. 38 to 44. 38 to 44. 38 to 45. Okay, so it's going to be in the 38 to 45 range. I'm going to, like, I don't know, back this up somewhere. I guess I'll copy it on my, whatever. I don't know. Let's go to the other submissions. Oh, I can make a note. That's really useful. So here I'm clicking, and it's going to be an old code. Let me find the Neetcode solution. This is the scene map, so that's not Neetcode. Map, set. So this looks like the Neetcode solution. Yep. Okay, so down here, notes, Neetcode solution. So I got the note there. That's cool. And I can make it a color. Boop. That's awesome. They got some cool. Tools over here. And then here, this note is jump past scene instead of while. Jump past scene instead of while. So 38 to 45. Now let's go over to the Neetcode. 38 to 45. Nope, I want to go over to the Neetcode. All right, I'll copy it then if I can't sort of like open it up. $38 to $45, $38 to $45. So it's gone 36 to 55. 31 to 55. All right. So it's a wider range with a faster, fastest time. I'm not sure how like trustworthy that performance test was, but it looks like the Neetcode solution can be faster even with the while, which is just mind-boggling to me that you could execute that many operations instead of jumping. But it was like a range around. It's just like more variation around mine anyway. So once again, they seem relatively equivalent, whether you go for the set or not. But it's good to know that there is a more elegant reason to choose the set. There's a more elegant reason than just it's the basic structure which conveys the information we need. That seems like okay, fine, but wouldn't you get an advantage from storing the index literal? Well, actually, that advantage comes with the cost of stale handling, and based on what we've seen, it really doesn't improve performance, notably. Um, Maybe it made performance more stable. Cool. So I am going to be very happy to just stick with the Neetcode solution here. And that's my conclusion for today. So join us tomorrow and we'll see if I can remember how to do it the Neetcode way. And my intuition, and notice how I'm building intuitive steps for myself. So my intuition is, oh yeah, I'd want a scene map. But then once I had the intuition that storing the index literal could be faster, it was really hard to pull myself away from that until I did it and I realized that the stale handling has an overhead because you have to min max on that stale handler to bind it in the range. And that overhead is like a net cost, basically. I still wonder if there's like a more elegant way to do that range binding besides the min max that I did, which was just kind of like top of my head min max. But I think there's probably a more elegant way that would be a little faster. Regardless, at this point, I'm content to let it go and say there's an additional reason to pick the set, which is that it divests us of the need to deal with stale handling. And based on the empirical data, even with cases that seem like you would expect the min max to win out, it doesn't. It doesn't. So I'm able to mitigate my extraneously complex intuition, basically, and go with the Neetcode approach, which should help make it easier to remember next time. But tune in tomorrow and we'll see.